Hi guys, welcome back to the channel. Jag here. In today's class, we're going to continue on with our definition of the first principles to find the derivative. So we're going to try this question taken straight from the textbook. It says use the first principles definition to determine dy over dx for y equals x squared minus 2x. All right, so what we'll do is perhaps maybe dy over dx. Okay, and I'm going to take the limit as h approaches 0 of x squared minus 2x. Okay, however, like we remember, we are going to actually substitute the x plus h, okay, and then square it. So I think we'll do that in like this next step here. Okay, and if you forgot like the actual definition, remember again, we'll write perhaps here, limit as h approaches 0, f of x plus h minus f of x, okay, and the whole thing is divided by h. Okay, so we really should be substituting it in here, so I'm going to put one more step so we can see that. Right, so the first time, let's use square brackets. I'm going to plug in x plus h whole squared minus like 2x plus h. Okay, close the bracket. Okay, and then you're going to subtract f of x, right? So f of x here is x squared minus 2x. Okay, and close the bracket. The whole thing is going to be over h. Okay, so hopefully we all remember how to do the first principles definition of the derivative, because we are going to move forward, okay, and also find the equation of the tangent line. So the limit as h is approaching 0. So remember, I'm just going to write on top here, this is x plus h. You're writing it 2 times. Okay, and then you're going to just FOIL this out. So this is x times x. We'll just open up brackets here, x squared plus x times h, which is 2xh. Then I'm doing h times h, which is h squared. Okay, and then you're going to close the bracket here. Okay, maybe we'll still leave it. Okay, in the square brackets, I'm going to distribute out the negative 2 here. So negative 2 times x, negative 2x. Right, and this is negative 2 times h, which is negative 2h. Okay, and now let's close it. It's very important that you are using the square brackets here. Okay, like you can see, we're going to open up and distribute this negative sign, or if you want to think of it as negative 1, okay, I'm doing negative 1 times x squared, negative x squared. This is negative 1 times negative 2, so positive 2x. Right, and then the whole thing, again, is over h. Okay, like we see here. And at this point, I don't need to do an extra step to remove the brackets, okay? I see there's x squared, negative x squared, which is gone, negative 2x, and positive 2x, and I'm just going to cancel it out. Okay, and so now we're going to just write down what is left over. So the limit as h approaches 0, I'm left with 2xh plus h squared minus 2h, right? And the whole thing is over h. So definitely simplify this out first, okay? So let's do the limit as h approaches 0. This is 2xh divided by h, which is 2x. Right? This is h squared divided by h, which is positive h. And negative 2h divided by h, which is negative 2. And in this final step, we're going to take h approaching 0. So I'm just going to put a 0 like this. We're going to put equals, and we're left with 2x minus 2. Okay, and we can see that basically this is the derivative of my function, which was y equals x squared minus 2x. Okay. All right, and so what we're going to do now, okay, is go to part B of this question. So let's take a quick look. It says determine the equation of the tangent to the function at x is equal to 3. Okay. So let's do it in like steps here. I think in the first step, okay, we're going to take our derivative that we had. I'm going to rewrite it here. dy over dx, and we got in the previous part A section 2x minus 2. So remember again the derivative of the function. This is the instantaneous slope or the instantaneous rate of change. So the slope of the function. So what we're going to substitute now is x equals negative 3. I'll do 2 times negative 3 minus 2. All right, so it says 2 times negative 3, negative 6 minus 2, which is equal to negative 8. All right, and maybe in brackets, let's write down that this is the slope, okay, of the tangent line. Okay, and it's the instantaneous rate of change. Okay, and then in part 2, we're going to actually find, let's write determine the tangent point. Okay, and how are we going to do that? We're going to take the original function, which was y equals x squared minus 2x. I'm going to again substitute x equals negative 3, okay, into this function. So negative 3 squared minus 2 times negative 3. All right, so this is negative 3 times negative 3, positive 9. And this is negative 2 times negative 3, which is positive 6. Okay, I'm going to add that together, which is equal to 15. Okay, also make sure you are using the integers, okay? Like in terms of the signs, always make sure you're taking the sign in front of the numbers. Okay, and so we'll put therefore my tangent point, okay, is going to be equal to negative 3 and 15. Oh, right here. And this is really important because now we're going to actually find the equation of the tangent line, okay, is what we are actually working on. Right, so let's put equation of the tangent. And this is really important. Remember, the equation of the tangent is basically a straight line. So it's going to be y equals mx plus b. And the m represents basically the slope, right? So we're going to do y equals negative 8x plus b. Then I'm going to take my tangent point. So let's put substitute your tangent point, which is negative 3 and 15. Right here, we'll put for x and y. Okay, so it's of course like what you've done before when you're looking for the equation of a line. So I see that y is 15. So I'm going to do 15 equals 8, negative 8, times x, which is negative 3, plus b. Okay. Make sure you're showing all your steps, okay? Just in case you want to just like check your answer, okay, on a test or a quiz, you have enough time to do that. This is negative 8 times negative 3, positive 24, plus b. I'm going to take the 24 to the left side. Okay, every time you go across the equal sign, okay, make sure you are subtracting. So I'm going to do 15 minus 24 is equal to b. Okay, and then b is equal to negative 9. Okay, and therefore, okay, my equation of the tangent, we'll write it over here, is y equals negative 8x, which is the slope, minus 9, which is the value of b. Okay, I'm going to box my final answer like this. Okay, so like you can see, there are only basically 3 steps here when you're finding the equation of the tangent line. The x point will always be given to you. In the first step, we're finding the slope because we already found the derivative. You substitute x equals negative 3. And you can see in the second step here, we're finding the tangent point by substituting x equals negative 3 into the original equation. This gives me my tangent point. And in step 3, we can basically substitute the slope as well as my tangent point into the y equals mx plus b equation. Okay, and remember, we're always solving for the value of b. This is the y-intercept. Okay, and that's our final answer. Y equals negative 8x minus 9. So hopefully you found this video helpful. And thank you for tuning in. Make sure you do share, like, and subscribe. And I'll see everyone in my next video. Thanks. Bye.